In this question, a body is suspended from a spring balance, and when in air, that spring balance measures a weight of 8 newtons. When that body is completely immersed in water, the spring balance now reads 1 newton. And we've been asked to use this information to calculate the buoyancy force. So what I'm going to do is just draw the appropriate forces on each of these bodies, and from that we'll see how to calculate buoyancy force. So I'm going to just draw the free body diagram of the weight itself. We have the force, which the gauge reads, which is 8 newtons, and we have the weight of the object. So that's in air. So we can work out static equilibrium, we can work out that the weight of the object is 8 newtons. Now on the right hand side, it's in water. So we still have the force of the spring, or where it connects to the spring gauge, but this time it's only 1 newton, it's reduced. We still have weight acting, even though it's submerged, it's still weight, which equals mass times gravity, but that's counterbalanced by our buoyancy force pushing the block back upwards. And this is what we've been asked to calculate. Okay, so let's first calculate the weight, which you don't really need to do, you could deduce it just from the diagram, but on the left hand side we would say that sum of the forces in the y equals 0. Because it's not moving, we have static equilibrium, so we have 8 pushing up and weight pushing down. So therefore the weight of our object is 8 newtons. And now we repeat the exercise for the right hand side. So it's still in static equilibrium, it's not going anywhere. So we have sum of the forces in the y must equal 0. So we have 1 newton pushing up, we have the weight pushing down, and buoyancy force pushing up. And that must all come to 0 because we have no movement. So we can substitute this. Weight was 8 newtons from above. That doesn't change. That's a material or object parameter. Okay, so whether an object is submerged or in the air, it still takes the same weight. It's the buoyancy that gives it the perception that it's lighter. So that's what we're trying to find. Plus buoyancy. And so we can rearrange, and the buoyancy force is equal to 7 newtons. And so in the next video I'll show you how to convert this, or rather to relate this, to the geometry or volume of the submerged object.